Hi guys, it's Boyan here. Today I'm going to talk about a CBT question of Maths of Finance. For this question, there are three bonds: Razak KL, Roma EX, and Cambridge LG. Three of the bonds have the same par value, which is 1000 each, and three of the bonds have the same coupon payment semi-annually. That means their payment period is 6. The question mentioned that all the bonds will redeem at the end of year 3. That's why their payment period is 6 period of payment. 6 payment. 3 of the bonds have different maturity value, which is the future value of the bond. For Razak KL is 1095, for Roma EX is 1070, and for Cambridge LG is 1125. As mentioned in the question, this is the question. And 3 of the bonds have different coupon rate and interest rate. For Razak KL, the interest rate given is I compounded semi-annually, I upper 2 here, and for Roma EX it's I plus 0.02, and for Cambridge LG it's I plus 0.01. For coupon rate of Razak KL, given R%, for Roma R minus 0.5%, for Cambridge LG R minus 1.35%. And we are going to find the variable of R and I. Determine R and I. In the question, given the summation of purchase price of the 3 bonds equal to 3,149.83 cents, and the purchase price of 3 of them is called R, S, and T. In the question, R given is 1095, so that means S plus R plus T, summation of 3 of the bond is 3,149.83. S plus T is 2,054.83. We use the formula of Excel here. C21 minus C22, that means 3000 something minus 1000 something, and we get the summation of S plus T. The variable here we are going to find is R and I. For the amortization schedule here, we are using it to check if our PV and our FV future value is correct. Okay, in this question I already solved it using solver. We will wanted to obtain the I and the R. Here, I and R. We are using solver for this question because there's 2 variables, R and I. The solver is under data and solver. We need an equation to equal to a constraint value. That means we need an equation to equal to a value. In here, we have our present value of S and T, which is Roma EX and Cambridge LG, is 2054.83. S plus T. The first half of the equation here is the present value for Roma EX, and the rest of it is the present value of Cambridge LG. We sum it together and we should get a targeted value of this. For this PV, present value equation, the rate is the semi-annual nominal interest rate of Roma EX, and this is the period of payment. This is the payment amount. We put negative here as the payment is money goes out from our account. And for FV, because FV and PV, either of them is negative, so in order to get a positive value, we put a negative here. And for the rest of the equation is the same. It's the rate, payment period, payment, and the future value of Cambridge LG. And summation of two of this should be this amount. And for the next equation, it's the R. Oh, sorry, I made a mistake here. R. For R, it's the present value, which is the purchase price of Razak KL. We purchase price equal to PV, present value, and this is the present value of Razak KL, which is equal to 1095. And we'll use the solver for this. I already solved this and solved it in order to show, and we'll change this value to 0.5. I think 0.5. It's just an estimated value. This is also 0.5. We wanted to make changes of two of this value, and we're going to use solver. In this solver parameter, we are going to set the objective to E32. E32 is an equation of S plus T. That means Roma EX and Cambridge LG PV. There are two PV summation, and we are going to set this column value to 2054.83, and by changing variable cell of this, which is the I, and D10, which is the R, the subject of constraint, because we have two variables, so we need to add a constraint, that is E33 here. E33 equal to 1095. E33 is here, the PV of R, which is the present value of Razak KL. And after we have this thing set, we are going to press solve. Okay, and we're going to press enter. Okay, for this question, the solver solve. The nominal interest rate compounded semi-annually is 8.31%, and for the coupon rate is 9.1% for Razak KL, and Roma EX, and for Roma EX and Cambridge LG, it's the relation between them. I minus for the rate is R minus 0.5%, and for the rate of Cambridge LG coupon rate is R minus 13%. And we are using this table to check whether our answer is correct or not. For Razak KL, the PV is 1095 and we get a future value of 1095. That means we get I is nominal interest rate compounded semi-annually is 8.31, and for coupon rate it's 9.1 for Razak KL. And for Roma EX and Cambridge LG is the relation between I plus 0.02 and R minus 0.85. This value we get here is R and this value we get here is I. And for Cambridge LG is also the same, I plus 0.01, and for coupon rate is R minus 1.35%. We are using amortization table to check amortization schedule to check whether our answer is correct or not. For the interest expenses here, we are using our balance times the interest rate divided by 2 because it's semi-annually. I upper 2 divided by 2. And for coupon payment, we are using this amount, coupon rate, and we use a formula here. This is the payment, D14 times D11, which is F times R, is the FR, coupon payment. F is the par value and R is the coupon rate, and we get coupon payment per year is 90.99, roughly 91, and because it's semi-annual payment, so we paid it half a year, that is 45.5. Our payment is 45.5. And for Razak KL, our PV and FV is the same. PV and SV is the same, so it's a zero coupon payment. And for Roma EX, we will get our maturity value equal to 1070, which is same as the question given. Roma EX. And for Cambridge LG, we will get a future value, that means a maturity value of 1125. Also same as the question given. So these three tables check our answer. The summation of these three amount is equal to, for this three question PV, we have it here. The present value of Roma EX is this amount, 999.74, and for Cambridge LG is 1055.09. After we add up these three together, we'll get a value of 3149.83, which is same as the question given here. We use this value to check our answer. Okay, thank you, and this is my presentation of this CBT question of Math of Finance. Thanks for watching.